Okay, second part of today's lesson is some problem solving with drawing and analyzing circuits. So just as a reminder, you might want to have a pencil, a calculator. You might want to have out your board notes or a printout of some schematic symbols, unless you've memorized them. And if you haven't done the background on this, you're way ahead of yourself, and it's probably going to hurt. Also, couldn't hurt to have out, go to today's assignment and print this out. Then you also have the hard copy in your hand, but you can see with better video quality the other problem set. All right, here we go. So the zero rule of problem solving is, first I read directions. Draw, label, solve each problem below. Show your work, neatness counts. I'm not too worried about my neatness. I am worried about my video quality. All right, a circuit has a 12-volt battery, a 24-ohm load. What is the current flowing in the wire? Draw this with safety and maintenance in mind. What? Well, okay, so let's just start. Underline what I know. There is my voltage, right? It's got a 24 ohm load. That is my resistance. What is the current? That is the unknown. What is the amperage? Draw with safety and maintenance. Well, safety means that I have wired it so that the wires don't melt or catch fire. That means I put a fuse or a circuit breaker in it. And maintenance means that I can turn it on or off. Means I should probably include a switch. So the way that I attack these is I always start with the voltage source. Because if I don't have a battery or an AC power supply, we're not having an experiment. So to me, it's always a good place to start. So symbol for a battery, right? I've just drawn a 2-cell, but it doesn't matter how many I draw. And I label it 12 volts because that's what it says. Safety or maintenance, I can draw a fuse, squiggly line. I'm hyper accentuating my connections, right? I might as well put the switch in right away because that's usually where the fuse is, right near the battery, and so is also your switch. And then I have a load or a resistance, or maybe it's several things, but whatever it is, it's got 24 ohms here. What is the current flowing in the wire? So one of the things to know is I read a current with an ammeter, right? And an ammeter is put in series to the circuit. So I don't have to do that, but it tells you to do it for other problems later on. So that's what solving for Ohm's law, V equals IR, gives you, is that ammeter reading. And I'm just going to draw a little thing here that says I equals question mark. What is the reading on my meter going to be? Well, there we go. I think that's pretty neat. Even at this poor camera resolution, you can see all the parts, safety, maintenance. All the parts are labeled. Now what? Oh, we have an equation. We have Ohm's law. Whoa. All right, so just rewrite Ohm's law, V equals IR. Even if I skipped, this person's going to get at least a C plus, right? They really know their circuit stuff and they know how to get themselves out of a problem. But at this point, I've got to do a little algebra, right, to find my I, right? So I equals V divided by R, right? So I've done my algebra step. Now it's my favorite, plug and chug, right? What do I know? It's 12 volts. It's 24 ohms. Oh my, the math comes out so nice, right? That is 1/2 of an amp, right? 12 over 24 is still a half. Yep. I don't even need the calculator. There we go, 1/2 an amp. Problem 1 is done for you. All right. Would it help if I went to number 5 and at least helped you draw the diagram? Maybe so. So if you don't need me, skip away. If you do, here comes number 5. I like all these problems because they're fairly realistic. You can tell I made them up myself. I like things that are realistic. Number 2 is actually out of my truck. I was changing the starter and I took my multimeter to the windings. Anyway, number 5, let's read the problem. An LED flashlight, oh, do I know the symbol for an LED? I believe I do. Has 2 1.5 volt batteries in series, and the wire, 1.5 volt, those are A cells, AAAs, AA's, C's, D's, all those are 1.5 volts. And usually they're stacked on each other, which means series. The wire can handle at most 0.2 amps. What resistor should be added in series with the LED, right, to slow down the current, since LEDs have almost no resistance? That's one of the things many circuit builders, when they're first starting to play with electricity, do, is they put LEDs in the wrong way because they're polar and they don't light up, or they put them in with no resistor and they just burn them up like fuses. They have a little pop, and that's the end of them. And we want to keep the wire safe. All right, so here we go. Let's draw ourselves the circuit for a flashlight. We're going to start with 2 1.5 volt batteries in series. So it's 1.5 plus 1.5, or 3 volts. I've probably got a switch on my battery. I don't think I have a fuse, but I could have one, right? And in this case, I can draw that ammeter in, right? And I know that I max is 0.2 amps, right? Just a window into the world. What resistor should I put in there? This is my unknown. And if you don't know the symbol for an LED, here you go, right? So it shows if I'm an electron, I can go this way through the LED, but if I turn around and try to go back, I hit the wall. That's how I kind of remember. And then LEDs also have the little light symbols coming off, right? Because without these, this is a diode, which still behaves electrically the same, just doesn't give off light. And there you go, right? If I don't put, and that's called a shunt resistor, if I don't put that shunt resistor in series with my LEDs, they burn out, right? And so putting that resistor in also lowers the current, and that's what makes LED lighting so efficient. All right, so there you go. You can do the rest of Ohm's law on your own, but you've got a good start. All right, that's our tutorial on today's worksheet. Hope that helped.